सर बोरास्कर सर
बोरस्कर सर नमस्कार.
आले का? कुठे आहेत बोरास्कर सर? वेर इज ही?
He is there.
हॅलो सर.
Govinda, can you share the slide, please? Good morning to everybody. So now we'll inaugurate webinar. And in this you can see the lamp here, and on behalf of Bhatkar sir and Professor Holger, we'll just light the lamp. Govinda, please. Click it.
Okay, good.
Stop the sharing. Govinda, stop the sharing. So good morning to all. Welcome. Welcome Bhatkar sir and Professor Holger for sharing your valuable time for this conference as a chief guest. Because of your motivation, we have this webinar today. I also welcome Professor Boraskar and Professor Lundvik, and thanks to them for sharing their time. Welcome to Guddi Didi, and thanks for sharing her time. I also welcome to our Neutrino group members, Dr. Ammanerkar, Dr. Rath, and Sharmaji. Welcome to all participants and students who are attending this webinar. Neutrino is not new as scientific for the scientific community. Many physicists, nuclear scientists have studied the presence of neutrino. They have tried to determine the size and neutrino and their energy. Scientists have simulated the energy of neutrino with models. So a lot of theoretical work has done on this topic. Last year at Mount Abu, we have a conference on science through silence. In this conference, we had a discussion on neutrino. The power source somewhere is continuously giving the energy, maybe by neutrino. How do you harvest this tremendous energy? Professor Holger, Dr. Bhatkar, and our team is now taking up challenge for the harvesting this energy. CIMET is a material research laboratory and will play a role in the developing of the materials for the neutrino energy capture or conversion. So we'll hear about this in this conference, about the neutrino, this energy, their determination. So within 2-3 lectures, we'll come to know what is we'll have some good information about the neutrino. as well as what is the status of the neutrino in the country as well as in the worldwide. Before proceeding further, I will request Didi to say a few words on this occasion, but I don't think she is there. So she has sent the message. I will just read the message. Dearest precious actors of this event, since a long time, true spirituality and science have been considered as a distinct. So we could not respond to each other's deep internal significance anymore in these crucial days of mankind. Spiritual silence and science have to stand together, not only externally, but and fight energy of the perfection of human consciousness and all the particles of matter, including space. If both stands close together, nourished by each other's mutual recognition, as the one is with them and shows them the way to new reclaims of artistic, energetic significance and expression. Science starts to work within the laws of the ever non-violent, ever failure-free, ever divine. So bring about projects and products that are alike in this very world that will soon usher in an era of new human awareness. So technological attainment of the peace and elevated selfness, intelligence. We can move into this event with a moment of silence to let up one's light into our Ruhani hearts and let it accompany us during this auspicious meeting. Didi. Thank you very much. Now I'll just request Dr. Amanerkar to proceed further for the welcome to the for the introduction of the speaker, guests and speakers. Dr. Amanerkar, please.
Thank you, Dr. Kale. Good morning, everybody. For this entrancing webinar, we have four eminent speakers, Dr. Vijay Bhatkar, Dr. Holger, Dr. Ludwig, and Professor Vasant Boraskar. We'll begin the webinar with the inaugural address by Dr. Bhatkar. I have a tough job of introducing him only in few words, which is already not a simple job. Honored with Padma Bhushan, Padma Shri, Maharashtra Bhushan, and a string of national awards and honorary doctorates, Dr. Vijay Bhatkar is best known as an architect of India's first supercomputer, Param, and several pioneering contributions to information science and technology in India. He did his PhD from IIT Delhi in 1972, where he was acclaimed as its distinguished alumni and went on to become its chairman of governing council. Currently, he is the national president of VIVA, that is Vigyan Bharati, chancellor of Nalanda University, and guiding India's notable national initiatives in science and technology, as well as in arts and humanities. Above all, most importantly, strong spiritual connect with the science is the most fascinating aspect of his polymath personality. May I now request Dr. Bhatkar to deliver inaugural address, please?
Thank you, Dinesh. Thank you for those very kind words and very gracious words. We are now beginning on this webinar, and I would say that as far as harnessing the neutrinos are concerned, I'm not talking about detection. Detection is a big field from its beginning itself, I think. So we are today talking about the harvesting of neutrinos for humanity as a whole, for the world at large. So it's a very important seminar because there have not been many webinars on this issue, even worldwide. And so we are all very pleased to be gathered for this webinar. I remember, to begin with, I remember Dr. Holger is here, and some of you know, of course, many of you who had accompanied me to Abu know that we are conducting in a very special ecosystem or environment, and that environment is that conducting science in silence, though we are speaking to each other. But and I remember Goody Didi, I think, who has inspired us to uh, create a special environment for this discovery. So I was often wondering when I heard this word, science in silence, um, and its importance. Here I remember, I think many of the major discoveries have come through in vacuum. And when you define vacuum, how do you define vacuum itself? And there have been many attempts to isolate a single particle in a box that there is nothing. But what does it mean that there is nothing? So there has been scientific attempts to identify a single fundamental particle, only one, I think possibly, and watch its behavior. It so happens that there is nothing like a vacuum, and vacuum is boiling with so many particles, so many things which are, I think, there's so much of energy in vacuum. So this requires to be investigated, and I'm very happy that we have assembled together in a very environment, at least in the mentally in our consciousness, that can we create very high science, great science, many discoveries, many inventions um, in absolute silence. And if you see that kind of things, there are several things, particularly in the Indian culture, the silence has been given the greatest importance. The most important accomplishment of humanity is that discovering your own self in total silence, in complete silence. And of course, we have the pictures of meditations like Buddha. I think we had different, he had advanced so many types of meditations, and silence has been given a deep importance. So it is in this context, I think we are trying to, in that environment or in that remembrance, we are trying to go on to some further advancement of the field of what we are calling it neutrino science, but not neutrino science alone. We are talking of neutrino voltaic technology. This was a word I was hearing first time from Dr. Holger when that what is neutrino voltaic? We know of course photovoltaic, and we don't know neutrino voltaics, but I knew that we are talking about technology harnessing energy, harnessing electricity. Voltaic means voltage. So coming from voltaic energy from neutrinos. So that is the goal, overall goal into this whole thing. And I really like that word neutrino voltaic. There's another word which came about, which has been that we identify ourselves with Homo sapiens, the entire humanity. Though I think as in through the evolution we have seen that we have come as Homo sapiens, uh, and that word has there is a wonderful book on that, Homo sapiens, and how Homo sapiens have evolved from the animals and from the whole evolution process. Uh, and we are now today talking about a world in coming from that Homo sapiens came from first time when humans or some animals started walking erect. So Homo erectus kind of things, and we were started walking. That was a big step humanity took, that they started walking on the earth, and now we see another very important thing, and this I also got from the articles of um, Dr. Holger and his colleagues, that we are talking about a new term which is coming before us for the entire humanity, Homo electricus. And when I read that paper, Homo electricus, that today we cannot think of, I think, walking on the earth without electricity. I think 150 years back, electricity, I think, was invented, and we have seen how the world has changed ever since. Today, we can't imagine the world without electricity. Electricity has penetrated so much, we just can't imagine that everything we carry must have is powered by electricity, and so much so that we are talking of huge power stations, and so many ways coming out, different types of energies, finally resulting in the electrical production. But today we are talking about something like the energy game is so critical, in the sense that the power of a nation is talked about in terms of its electrical productions, electrical distributions and systems. And now it has penetrated back to, in our pocket. We carry this, I think, this device which we carry, it has got a battery, and the battery and battery management happens to be the most important part of this technology. Not only the processors, the memory, the storage, and all kind of the softwares which are there, but the battery management has become the most important issue. And we are going to talk about this technology and its implication for this technology. Today, I think for the population of about, say, 7.5, or very soon 10 billion people on the earth, I think everybody would be carrying this device in his pocket. Not only that, one major change that has occurred is that we are not talking about this, but everything on the earth, every artifact, be this table or the chair or of course this device, everything will be connected. I think what we are talking about through Internet of Things, IoTs, and there are, we are talking about, there may be, if there are 10 billion people, and there will be at least 100 billion or 1 trillion devices hanging around, yeah, everywhere here. That day is not too far. See, we never imagined that everything will be connected on the internet, and it has come now to us, onto the computing devices, to the television. But we are talking about anything. If it exists, it will be connected by internet. So IoTs have become very important. But then, how do you power those IoTs or IoEs, Internet of Everything? How do you power them? How do you distribute them? That has become so whole thing has shifted from this issue to how to power these devices, and we require a different way of doing it. At the same time, another issue, which is like a pandemic, is a very important. Before pandemic came last, I think we have gone through it last year, the whole of the year. But the issue which was being discussed simultaneously was the issue of climate change. We have been talking about climate change, and that was the issue that was dominating. And suddenly the pandemic comes, and we are seeing another challenge before us. Anyway, what I'm trying to say is that this issue, how to power these devices, and how much power will be required, and if you generate these things through the present mode of this one, so huge power stations which started coming 150 years back, some power stations, and then their developments and gigawatts power stations, and we are talking of terawatt power stations, and kind of environmental damage that is creating, that we will not be able to sustain that. It is in this context, I think, Neutrino appears on the scene. The Neutrino has been there, as Dr. Kale said. And Dr. Kale, I'm very thankful to you for organizing this webinar, because I think we need to discuss, understand, and discuss more and more on this, and so much to be understood on this and its impact on the society. There is, of course, the physics, there is mathematics, and but also the impact on the society the Neutrino can have, and we are forcing in front of us. And today we are discussing, thanks to Holger and the team, the German team, and thanks to Goody Didi that I got introduced to you, Dr. Holger, and it changed my way of thinking. I think it is there. I met also Thorsten Ludwig, Professor Ludwig, and he started showing more, I think, physics aspect of it to us, and he's being a professor of physics in the Technical University of Berlin, and that opened up new windows for me understanding this one. Today we are with also Professor Boraskar, whom I have not met so far. He's a research professor in Sung Kyun Kwan University. So I will be getting introduced to his contributions or his researches in this field. And we have Dr. Rajendra Kumar, and most notably, I think I must say that I'm looking forward to Dr. Bharat Kale and team, how we are taking forward, how we will be collaborating. One thing which has happened, and we have seen this also in this great pandemic, and I believe now all major breakthroughs will have to come from various collaborations, from worldwide. Pandemic is like a worldwide collaborations. If you have to make the breakthroughs in any of the things like that, and this breakthrough of what we are talking about on the neutrino voltaic or neutrino sciences and technology, neutrino science and technology will also come. I think we'll have to do the worldwide cooperation, and I think we are showing in the early steps of that, the collaborations. As far as neutrino itself is concerned, detection, this field has been there for a long time. I think we know that I remember the experiments which were being done in India in the Kolar gold mines, that for the detection, and those experiments have advanced since then significantly all over the world, and also in India. Just I think very recently, very few years back, we also launched a major observatory called Neutrino Observatory. It's national laboratory uh, for detection, and the budget for that is something like 1,500 crores. Uh, 1,500 crores will translate into something like $200 million, and such experiments are going on in almost every country, almost major countries who are advancing their technology. For example, in Germany, there's a big experiment. In Japan, there's a big experiment. In US, and all the things. So there is a detection which is going on. The current detector, which I think we are trying to build, is about, I think, mm, in near Chennai, the new detector that we are trying to build, 4,000 meters down, I think, 1,500 meters down, and to about 4,000 feet in Chennai. The big tunnel is being something like a cave being constructed, which is all instrumented, and we have new lights being thrown on that issue. So detection is one major issue on the physics of that and mathematics of that, and there is something. But I think the thing which we are going further than once we have detections, and we know this one, where there is a shower of neutrinos coming on the non in the universe. This emanates from the sun and stars, from the and there is so much of this. The billions of these particles are passing through right now in front of us, and through everything that exists on the universe. How that can be harnessed is the issue. How that can be harnessed, and what manner it can be harnessed. And I think the name has come, like there is a shower of photons coming from the sun, and that has led to the what we are now today talking about, the photovoltaic technology, which we are trying to harness, and we never thought it will harness in such a large term that the, by 2040 kind of paper which are coming out, that the dominant part of the energy will come from this photovoltaics. I think in India itself, we are building gigawatt stations. We are building so many farms we are being built for harnessing this power. Now, it is in this context we are looking for learning what is the contributions that will come from neutrino, and we are calling neutrino voltaic technology, as Holger has called to this one very appropriately. But it is not. It is going to be harnessing is going to be a different kind. It is not exactly the manner the photovoltaic technology has done, and that is going to be a great innovation. It is in this context, I would say, that when Dr. Holger and team demonstrated to us something on through the video conferencing, and that how it is harnessed, what are the materials involved. I think why when we say that these two teams should collaborate together, then I approached Dr. Kai, that is a CMATE laboratory, the Center for Materials for Electronic Technology. CMATE was a laboratory which was with for a lot of far-sighted it was built. No, Dr. Dinesh Manerka was involved. There are many of my colleagues were involved, and my lab, CDAC lab, was involved. That you please nurture in the beginning. Let's so, and I see the CMET lab, and then suddenly started thinking that if the CMET, which is also working on batteries, which are not electrical cars, and the materials for that, and also on the storage issues, if CMET gets involved in this whole process, I think that we can make a very not only in detection and physics, we can make a great contribution for harnessing this technology. And that's why we said, Dr. Holger, let's have these interactions. Let us sign the MOU. Let us collaborate together on this issue. And I'm sure with so many physicists, so many material scientists, so many people working from Germany and under Holger's team, and of course from India, I think, which is harnessing is a totally new subject for us. I think in thinking how do we do that? And if we collaborate, we have some early, we have some breakthroughs on this. This is the technology I believe is like a disruptive technology. What they call today's world, today's parlance, that something once this comes, everything will get disrupted. And this has happened again and again. Like pandemic is a disruptive happening. We are not prepared for it. Nobody is prepared for it. But such a thing happens, and we have seen the whole world was shut down some way, and which we had never anticipated before. Similarly, in a positive sense, in a very positive sense, if such a technology comes, whole problem of the energy for the world and the energy is growing, requirements are growing exponentially, and well there is an immediate implication of that, the energy, but there is another disaster looming on that, that is the climate change, which is the price that we have to pay for it, will have to pay. It is in this context that this can be a disruptive technology, but Neutrino does not require that kind of thing. Which the power requirements will be very, very small. We have seen that how I think today in this seminar we will perhaps see a demonstration. What Dr. Holger has shown us how a foil, a substrate on this kind of thing, doped with graphene and other materials, I think can create a how do you call noticeable voltage difference, and that start making a change in some devices like calculators or the mobiles. And of course, I have talked about IoTs and the IOEs, and suddenly there will be a different kind of impact. The impact is not just this one. The impact is that there's a pervasive way, a very pervasive way it will impact the entire humanity. We'll be carrying the showers of course, we are here everywhere. There is showers of neutrino, and they will be tapped for all the things what we do in this thing. So the name suddenly which was given was that we'll now not be Homo sapiens, we'll be Homo electricus, because electricus means without electricals, the humans with enabled, empowered with electricity. I think which will be tomorrow, which will be embedded everywhere. I think will be sunrise as we carry our mobiles, thing. So how to do this? How to do this breakthrough? And some people are very far-sighted. They see this impact. They see this impact. They see the opportunity. They see the technology, and that once the technology comes, the whole breakthrough happens. What has happened like 150 years back when electricity came, and then we see the whole world was lit up with light. I think, and then everything happened around this. So we are seeing what I wanted to bring to fore, or to which all of you know, that this has a potential of that kind. This is a potential of that kind. We are talking about it. We are pioneering it in the sense that we are imagining. I was saying, imagining that there will be tomorrow's cars, tomorrow's not only mobiles, but tomorrow's vehicles will be powered by this. And this was the imagination Dr. Holger brought before us, and they talked about the car called was named as Piecar, Piecar, and he will explain what is the thing, why it should be is more appropriate name mathematically. So it can generate almost infinite power, infinite energy, not in that term, but one which is by imagination, it's endless. thing which by mathematical terms. So that's why when I was looking at, I see infinity, the symbol of infinity behind him. There is electrical light, and there is a so it's very telltale that is electricity in a which can scale to through these devices into infinity. But the challenge remains before us before this seminar. In the seminar with the thinkers here, the experimenters here, and physicists here, is that how do we tap this? How do we harvest these things, which we are going to discuss. From the, I'm very happy that we all come together for a collaboration for working this kind of thing, making initial breakthroughs, and once a breakthrough is made, and once I think the whole world can change. This was what Einstein said, and I think there is Einstein by giving the equation E is equal to mc square, by giving the photoelectric effect to the world. He gave the photoelectric effect, and of course, we have seen the impact of photoelectric effect. The world changed. So today we are talking a breakthrough of that kind. It will take some time. It will take a lot of thing, but in the collaboration, understanding, and lastly, I will say that make a breakthrough. I would finally end with my thing is that what Einstein said rightly. It was the imagination. It was the imagination that is more important than invention or innovation. I think what Einstein imagined, and he did not connect any experiment, but through that imagination, he changed the way we look at the world. Similarly, talking about neutrino voltaic as a technology. As a technology, I'm not talking about the effects were known, are known on so many years. But looking at a commercially viable technology which can pervade the entire world, humanity, is a great, I think, great imagination, and it can be done. And we are seeing some of the initial realizations of that. And I wish the entire team, I think, whole team, who are investigating this breakthrough technology, which will bring a new hope for the humanity. Otherwise, we are all doomed in certain because the current technologies cannot continue, because you have seen the great the catastrophic effect it can have on the humanity with such great potential possibility. So this webinar is very important, Dr. Bharat Kale and Holger, and I said that having physicists like Ludwig and Boraskarji, and so I think we are all eager to hear all of you, listen to your thoughts, and take this innovation, this quest forward to infinite energy at very less cost and without damage to the planet. So this is a great. Thank you very much for. I think we have started this seminar with lighting the lamp, and that so we are now trying to light our own lamp in our brain, that how this should be done. So this seminar, great, have a great time ahead, and let us share our knowledge. Thank you. Thank you.
Thanks, Dr. Bhatkar, for putting the subject matter in the proper perspective. Keynote address for this webinar will be delivered by Dr. Holger Thorsten Schubert, CEO of Neutrino Energy Group, Germany. He's basically a mathematician, entrepreneur, and philanthropist. He has never been satisfied with the ordinary accomplishments. Long-time patron of the arts and sciences, Holger has simply applied his philanthropic passion to the subject on neutrino voltaic devices, which he believes holds the great potential to help the human race in a unique way. Let's hear about this exciting energy conversion pathway from Dr. Holger. May I now request Dr. Holger to give his address, please.
Yes, good morning to everybody. So I'm very happy to speak to the Indian audience today. And I would like to take this opportunity to wish you a great deal with health and happiness and satisfaction for the year 2021. Today we are now discussing a very special issue, for over 10 years, I have been working on it every day, and it has taken a while to get to the mainstream. Today, we have the recognition that we have access to the limited cosmic energy, and that is exactly what humanity needs to continue. And I want to say my very special thanks to Dr. Piecar to make the things so clear at the beginning, because this is very important. We are talking not about a dream, we're talking about hard technical and physical facts. And we are now called upon to use these findings and translate it into touchy technologies. And this, therefore, it was very, very important not to come in any conflict with the basic researchers for the neutrino research, which are working with the detectors and working with the accelerators, so that we make it very clear neutrino energy is not the neutrinos energy only. So neutrino energy means the invisible spectrum of radiation, which we want to use for practical things. And I will tell you, I will come a little bit back to the roots of the technology, and you will totally understand why I'm today also speaking to the Indian audience, and why I like to come with this technology to India. And I'm very, very happy that we have this collaboration with CMET, because I think we need the best knowledge, and we need very awake and creative individuals which are using this knowledge and take this knowledge to change it, to really translate it into the touchy technologies, because this is important for the people, that they can have something inside their hands for practical use. I like to go a little bit back to the time when I have started with this topic, because you have to understand how I come to neutrino energy, neutrino voltaic. I'm trained as a mathematician and a business manager. This was my business at the beginning of the 1990s. I was very successful, and all the money what I made at that time, finally I invested later in the research. My father was a nuclear physicist, and my mother was she was a chemist. So science thinking has been one of my habits since I was in the children's shoes. And my brother and me was always asking what we can do when we see things, how we can improve it. And my father, he also was involved in the beginning of the photovoltaics. And when he came to one home, he was traveling around the world and constructing this nuclear power stations. But he came to one home from the US. I can't remember, 10 or 11 years old. And he was bringing the first solar cell, photovoltaic cell. And he explained that it's possible to use the light to make energy on it. I can remember I was going to school the next day, and I was telling my teacher that we are able, my father is able to use the light to make electricity. And they said, this is impossible, totally impossible. But I saw it, we were able to see it. But from this moment, it cost a couple of years to see this technology the first time in action. In action means for me, it was in the calculators of the Texas Instruments. At that time, the first solar cell, and it doesn't need a battery. And this was for me something, even as a child, to try to think about it and to know more. But after the university, I came to the real estate, and I was CEO of a big German real estate company. But I never lost the sight to to this kind of technologies. And I always was thinking about how maybe can we this kind of solar technology better, and that this happened. So the solar technology started to come in the daily room of the people, in the houses, in the little gadget, and the solar came. But even today, solar is just a part. What I want to explain is that the global system of energy supply today is built on the idea of central production. So when we talk about neutrino voltaic, we have a different point of view. We are having only weak force and weak energy. But as a mathematician, I can tell you the sum of all this weak energy is much larger than all big power, all these big things around the world, and all this system as we have today. We doesn't want to speak badly, because this system was born more than over 100 years ago, and it was useful at the moment in the time of early industrialization. But today we come to the, I will use a hard word, to an abyss. We come to abyss. This is a question, the point of view, because today we see all the negative influence of that. And especially in India, I saw in the television all the smog what you have. You can't breathe. The air is polluted by the climate. Maybe we have a climate change, man-made or not. This is not a question today, but we know all this kind of pollution this is very bad. So we have to find something new. Otherwise, the abyss are coming closer to many reasons very quickly. The key to change something is the knowledge. And the knowledge comes to me at around 2008. I was continuing the research of the photovoltaics. And the one professor in Switzerland, he made particles smaller to have a larger surfaces to increase the power of the solar cells. But when he made it too small, he found vibrations. And these vibrations were not useful for the photovoltaics. And there is a very nice study of a technical high school of Zurich. And this is a little bit one of the basics of this thing. What we are doing now in neutrino voltaics is the atomic vibration in nanomaterials and nanocrystals. So these findings were very, very important, especially that soft surfaces vibrate strongly, and the soft surface, what we are using, is this graphene between two layers of silicium. The patent what we have is the patent for a graphene sandwich. And why this is so important? Two things are necessary to use the technology. First, we have to know that in the vacuum there's some energy inside. And as we have learned by Dr. Piecar, so thank you very much again, there's a lot of things inside. But the problem for man is that if you can't see something, you do not believe that there something is inside. And so in the research, it was a very important point when the neutrino was not only was postulated, when the neutrino had a clear mass, and because if something has a clear mass, it also will have energy. And today we have that one single neutrino, we even know exactly that one single neutrino have something around one electron volt. This is just a very little amount of energy, but we have billions, and we have it not only, we doesn't only have the solar neutrinos, we have cosmic neutrinos and many other things. And as we have learned, we not only have the neutrinos, we have a lot of other things and electromagnetic radiation. And the second thing is, when you see how electricity will produce even in the nuclear power plants by magnet, so you understand, and they have, this system is a system of huge production of huge amounts of energy by AC, but the AC is only needed for the transportation. So the AC is only for these people which have to transport energy by thousands and thousands of kilometers by 380,000 volts. But all this electrical little gadget, what we use today, are very, doesn't need the AC. And so we have to find, a way to have the energy, the electrical energy everywhere. And there we need a clear technology. And this is it's a mechanical thing, but it's a quantum mechanical thing. So we have now a quantum mechanical technology that we are able to convert the energy from the neutrinos and the other electromagnetic waves into electricity. And what we want to do within the next years to implement this technology in any electrical device. And I tell you the story by the Piecar, because then you can imagine, when you think about a car, you can imagine this frame of the car can also be the cube at home or a little cube in any electrical device. And the story, what I will tell you now, this is a very special story, and I never told it before, because this is something totally new. I have a very special paper here, and I will give you some citations. This special paper is from the Royal Institute of Technology in Stockholm. This paper was a hidden paper. It was not open published yet. This paper is the study for potential of harvesting solar neutrinos to power electrical cars. Something around 1.5 years ago, from a very large German manufacturer, I will not tell the name yet, the chief engineering officer was sending me an email. I was very surprised to see that. And I called him back, and he said to me, "Oh, Mr. Schubert, we were looking about that, what you have published, and we want to have a meeting with you." Okay, I had a meeting with him. He came to our office to Berlin, and he told me that they were looking about that we are doing, and they have some conflicts with the basic researchers, because neutrinos are so weak and it doesn't interact and so on. And he wanted to know a little bit more about that, what we are doing. And I explained him, I showed him, I demonstrated him. And we also made some NDAs, and he was involved, and then it was silence. 2 weeks later, he came back and he said, Mr. Schubert, I have talked to my board of directors, and at this moment we can't work with you. And I asked him, yeah, why? It's very simple. Maybe we believe in the technology, but our company has invested something around 30 billion in technology of charging electrical cars, and we have the next models coming up to the market now in 2020 and 2021, and we have so much money invested that this disruptive technology, you maybe come back in a couple of years. And then it was silence, and it doesn't do anything. And even in the German press, you know, the people are, it's very difficult to have this topic on the mainstream. But we will continue our things, and now, first time, I will let you know a little bit about this study, because this is very, very interesting. And I know now that we are really on the right way, and we are really on the right way to do it in India. And this, so this disruptive technology will come now from India and not from Germany. They had to have the chance, but they are not grasping it. This study of the Royal Institute of Technology in Stockholm, and you have to know that the Royal Academy and Stockholm, this is the same university which are responsible for the Nobel Prize in Physics 2015, to give the Nobel Prize in Physics to scientists to prove that the neutrinos have mass. And I think that this big car manufacturer especially used that institute in Stockholm because they wanted to know it clearly. So I was very much surprised by this study. Came to me by an intelligence service officer from Switzerland. He arranged it for me. And they have a lot of questions inside the study. So the study was a demand of sustainable mobility, neutrinos, about astronomical carriers of energy, and of course all that what Dr. Piecar said at the beginning, the detector technologies, all this historical research, all that what was done, everything what we know. And they wanted to find out if there is a possibility that these astronomical carriers of energy are, if it's possible to use this kind of energy to power electrical cars. And they really make it, this study shows it about solar neutrinos. This is especially with the solar neutrinos, they are not using the other neutrinos, but they calculated exactly and everything what have to be found out. All the state of the art of solar neutrino technology, solar neutrino detectors, that we know with the Karlsruhe Institute of Technology, that we have this 1 of electron volt for each neutrino, that we have 60 billion a second, and that we have a part of this will be coming to interaction, that we have this Walter-Cherenkov technique and the superkamyokites and all the other kind of detectors, and the boron experiments, and they come, and this is very special. They come to our patent, and the question was the solar neutrino energy converter, and the converter about this patent what was published, and they created this foil in a lab. They made really 12 alternating silicon graphene layers on it, exactly as I prescribed. And they calculated and tested and they measured, and they come finally to the, and they have on the other side, they had the energy need of electrical vehicles, and they give an estimation of the energy which is needed to be harvested from the solar neutrinos. And they found out that they need for a car of a length of 4.76 meters and a weight of 188, with a leading surface, they write a leading surface, the total surface of the car, it's nearly 10 square meters, and they wanted to have 80 kilowatt to have a range of around 300 kilometers. And they calculated and they say, okay. And now I tell you what is really special. They found out that we have, so we had a little bit more, that is first, we have the neutrino flux, the energy flux obtaining from the different solar neutrinos, only the solar neutrinos, is listed as 19.49 watt square meters. So, and then they calculated, they tested, they measured, they find it, and they said, oh, the problem is the surface exceeds the surface of the car, which is below of 10 square meters, maybe, therefore, this is too small. So we have only 10 square meters and we have a 19.49 watts, so with 190 watts. But this was the wrong conclusion, because as we have learned, we can stable it. And when we have not one layer, because the big advantage of the photovoltaic cells is, of the neutrino cells, the opposite of the photovoltaic cells, we can stable it, we can stack it. I don't know how many, we doesn't test more than 100 yet. Maybe we can do it with 200, with 500, whatever. So what they said, okay, we have 10 square meters, we have a 19.49 watt square meter, so 190 watt only, it's not sufficient enough. Have we 10 lines of that? And this is exactly what we want to do now with CMAT. We want to make this frame of the car totally made of this material. And then we have, for example, when we have 10 layers of this materials, we will have 1,900 watt. At 50, it's around 10,000 watt. And when they write, they need 8 kilowatt, then exactly that what the car need to be charged in 10 hours. But the advantage is that our car is only parking on the road without using any kind of cable. And we does not only have the neutrinos, we maybe have a lot of more. And now when we come from a normal car, as we know, with an engine to an electrical car, everybody knows, especially in your area, in India, as hot the frame of the car becomes when the sun is shining. But these are not the photons, this is the electromagnetic wave. And the car is so hot, and all this energy inside the car, you start the engine, you open the windows, you start the air condition, you destroy the energy. So inside the frame, inside the body of the car is so much energy, and this is exactly the energy what we will convert into range. And as I was saying at the beginning, this technology, when you close the eyes and see the car and you understand why this car is able to go without to be loaded by a cable, you can imagine that this will work in any other size too. So because we can do the same like the people of the photovoltaic do, we can scale it. We have the advantage, we also can stable it. And after the Royal Academy of Science made the study, it's very important. Not we made the study; they made the study. Before the study arrived, I was anyway sure that it works because we measured it in our own labs. But now they have approved it, and I also expect, like Dr. Piecar said, that when this kind of knowledge will come mainstream, very, very quickly, this technology will become disruptive. But we should not make, this is not a bad way of a disruptive technology. This is really a good way of a disruptive technology because the energy needs are growing and growing. And by using the energy which are around us, the neutrinos are part of that. We have with this neutrino voltaic, the first time really after the photovoltaic technology was, and the technology where we're able to use it as the technology which will really help all of us in the future. And I really, today I doesn't want to take too many things about the details of the technology, about how it works exactly. But just a few words is that metamaterials, so the vibration of the graphene between the silicium layers, this quantum mechanical effect, this is something where everybody of the audience is able to double check it. So if anybody will tell you in the future, our neutrinos are too weak. Yes, a single neutrino is weak. But we have today a technology to convert the invisible spectrum of radiation into electrical power. And I finally have a call to everybody who understand what I said today. Without any doubt, we know that we have enough invisible spectra of energy. Not only enough, really a lot. Without any doubt, we know today how to convert a part of it into electrical power by quantum mechanical technologies in neutrino voltaic. We know it. We know what we have to know to let it happen. And it's simply our duty to use that knowledge now to make life on this planet better. Not only for ourselves, we should do it for peace and we should do it for freedom. We should do it for our children and we should do it for the future generations. So thank you very much that you're listening me, and hopefully I will have shortly the possibility to tell you more about that. So thank you very much.
Thanks, Dr. Holger, for sharing your interesting entrepreneurial journey blended with researchers' enthusiasm. Now we'll move on to special innovative talk by Professor V.N. Boraskar. Professor Boraskar is well known for his significant contributions in nuclear and solid-state physics with more than 200 research papers in frontline journals. He has produced 28 PhD students while mostly working at Pune University. Besides Pune University, he has served as a director of the UGC DAE Consortium for Scientific Research at Indore in India. He has held several visiting positions in Japan, Sweden, Canada, Czech Republic, and of course South Korea. Currently, he's working as Brainpool Innovative Scientist and Research Professor at Sunkyunkon University, which is also known as Samsung's University in South Korea. He possesses equal proficiency in theory and experiments in the domain of accelerator and radiation physics, radiation processing of materials, nuclear reactions in electrons and heavy ion induced defects in semiconductors and devices. I have myself seen Professor Boraskar working in Sangyunkon University at the age of 71. I think now he's as old as India because he was born in April 1947. So Professor Boraskar, yes, I will say still young in his attitude, and I have seen him working, with his hands in the laboratory, which is not so common for a person like me. May I now request Dr. Boraskar to deliver his speech.
Thank you very much, sir. I'm audible now?
Yeah, you are audible now.
Okay. So first of all, I would like to thank Dr. Bharat Kale, Director CIMET, inviting me to give a talk on basic aspects of neutrinos. So I really appreciate that this kind of webinar is being conducted, as Dr. Bhatkar already said, first time in the country. So this is really a new field for me also. And we are looking forward to have really useful applications of neutrino in future, as Dr. Bhatkar has already explained very nicely. I am really impressed by the talk by Dr. Bhatkar, where he has explained very nicely the present application of neutrino and the status of the research of neutrino in our country. Now, the Dr. Holnagar has already explained the practical applications of neutrino. He has already demonstrated in his laboratory, which I think in India were not yet done to the best of my knowledge. But as with the expertise of CIMET, we are very hopeful that in near future, we'll also have a device working on neutrino. So I'm thankful to Dr. Ammanerkar for a very nice introduction. We really enjoyed working with him when he was in Singapour University, and we hope to work with him again in near future. So as introduced, I will be talking on the basic aspects of neutrinos, but I will not be touching any application of neutrinos because the other speakers have already described and will be covered in the next lecture by Dr. Thorsen. So I'll just start with my talk. So my topic of today's talk is an introduction to neutrinos, origin, types, and detection. So this is not a talk for the experts, but it's just for the beginners or those who are having research work in the field of material science or other disciplines other than nuclear physics. They would like to know about the basic concepts of neutrinos because India government has already made a laboratory in the country, as Dr. Bhatkar has already explained, and also CIMET is going to have a big research program. So it is, I thought it is better to just explain the applications of neutrinos. Instead of application neutrinos, the basic concepts of neutrinos, what is neutrino, how they are produced, and how they are detected. So, as already explained by earlier speakers, universe is filled with the neutrinos. Though we are not able to see them, though we are not able to feel them, but still the neutrinos are around us. So the format of my talk will be introduction to fundamental particles because the neutrinos come from them only as a part of the fundamental particles. Then the properties of neutrinos, some basic properties of neutrinos I will cover. Then types of neutrinos, origin of neutrinos, and detection of neutrinos. And if time permits, I will also cover which is called neutrino oscillations, which is the current topic of research in our country and also in other countries. But I did not include in my format, but if time permits, I would like to explain the meaning of neutrino oscillation, which is of current interest to scientists working in that field. So I'll just start with the beginning that we know the atom, which has neutrons and protons, and the electrons are moving around it. So earlier, when the neutrons and protons were discovered, it was thought that they are not divisible, means the proton is not divisible or neutron is not divisible or electron is not divisible. But that concept was there. After that, it was found that the particle, which is proton and neutron, so we have a molecule which is made of atoms, and atoms are made of protons and neutrons. So earlier it was thought that neutrons and protons are not divisible, but now it is known that the proton and neutrons are also divisible, and they are formed by another particle which are called quark. So the fundamental particles, when we say the particle which cannot be divided, that is the definition of the fundamental particle. And therefore neutron and proton are not the fundamental particles, but quark are the fundamental particles. So this is a basic concept about the fundamental particles. Now we come to electron, because electron is also a part of the atom, but electron is also not divisible. So far, Nobody has so far reported, but we don't know in future somebody may come with the concept. But so far, today's knowledge, the electron is not divisible. So electron comes under the category of a lepton. So I'll just explain you the meaning of lepton. So before that, because this is be a part of the radiation, so I'll just explain what is radiation in earlier. So nuclear stability, so the stable and unstable isotopes. So in the universe, or so far, more than 1,500 different isotopes are known. Out of these, only 264 are stable and do not decay over the time. So somebody may ask question that what is the meaning of stable and what is the meaning of unstable? So the factor, because we just now saw that atom consists of a neutron and the proton. So nucleus, we call it the nucleus, and the surroundings are electrons. So the factor which affects the stability of nucleus is the ratio of neutron to proton. So how many neutrons are there or how many protons are there in a nucleus, that decide the stability of the nucleus. So too many or too few neutrons relative to protons makes the nucleus unstable. So I will just come to this aspect, then I will come to neutrino because of that. So again, I will just repeat the definition of the stable isotope. So in stable isotope, the number of protons and neutrons do not change and remain the same forever. Say for example, we use everyday aluminum, we use copper or we use iron, we have gold ring with us, silver chain, or all these elements, or we can say isotopes, are stable for years and years. There is no change in them. Whereas when we go to a radioisotope, so they are unstable elements. What is the meaning of unstable elements? Because they emit radiation and therefore they are called radioisotopes. So if you call only isotope, it means it is stable. When you say radioisotope, means the element is emitting radiation. So each unstable element can decay by emission of a negative particle or an alpha particle or a positron, or by emitting other particles are not possible, but so they reach to stable. So in our life, I always tell to students, as in our life, we want to go to stable state. So nature also has the same tendency. A unstable element or radioisotope will try to decay, get rid of the other part, and goes to the stable state. So the same way as we have a philosophy in our life. So the number of protons and neutrons of an element changes when the emitted radiation is a charged particle. So this is very important. If gamma rays are emitted by a radioisotope, it is not going to change the element. But only when positive or negative charge, say positive charge radiation, or say positron or alpha particle, they are positively charged particle, whereas a beta particle. So beta particle is exactly same as the electron. So we call it as a negative charged particle or electron, such as a beta particle or alpha particle. So when the element goes, the other process is called electron capture. So all these processes changes the elemental structure or the neutron to proton number, and therefore the element changes. So the nature has made, it really is a wonderful thing that the plot you can see that the x-axis and y-axis is the number of neutron and x-axis is the number of protons. So the pink color dash lines is a stability curve. So what it means that an element lies on the stability curve, remains stable for its size. But you can see that the stability curve, the neutron number is not equal to proton number. I have also drawn another line where the neutron number is equal to proton number. But the nature has not accepted it, but there is another stability line nature has made in which the neutron number is always greater than the proton number. You can see any element where the neutron number will be either equal or more than that. So for example, zirconium, it has got 50, the mass number of the zirconium is 90, and the 40 is the proton number and 50 is the neutron number. Similarly, tin, you can see it has got a 50 proton and 70 neutron. So the stability line shows you that the neutron number is always greater than the proton number, but it is not the condition for stability, but this is what we get from the nature. So if any element lies on this line, then it is called it is a stable element or stable isotope. If it is goes above or below the line, then it is not stable, but it will like to come to the stable line by emitting radiation. So for example, the stable line is drawn there. You can see the line stable. So if element is sorry. Sorry. So if the element is lying above the stability line, then it is not stable. But as I shown by arrow, the element would like to come back to the stability line. Similarly, if the element is lying below the stability line, it will like to emit radiation and come to stability line. So the line below the stability line will emit positron, because if you see the line, in that line, the proton number is more as compared to neutron number. And therefore, the proton number decreases. So the emission of beta positive decreases the proton number, whereas the line above the stability line emits negative beta particle, so it comes to stability line. So in this way, the stability of a stability of a isotope is decided by the neutron to proton ratio. And that's why we have a beta minus emission or beta plus emission. So this is I'm telling because in the case of neutrino, these radiations are very important. So beta plus radiation or beta minus radiation, they are very important to understand the origin of the neutrino. And therefore, I have just taken this plot to show you that there is the emission of positron or the emission of a, so positron means beta plus particle in which proton changes to neutron, and the emission of a beta minus particle in which a neutron changes to proton. So the neutron number and proton number, the ratio remains the same required for the stability line. So I'll just come to elementary or fundamental particles. So there are broadly two types of particles are existing or defined or classified. One is called boson. So the particles having spin equal to or integer number of 0, 1, 2, 3 are called boson. And other particles which are categorized as the fermion. So particles having spin equal to half integer or multiple of half 3, 2, 5, 2 are called fermions. So the neutrino comes under the category of the fermions. So that's why I just drawn this classification just to separate the consistency of the boson from the fermion. So this is a plot which is not, of course, not a good slide, but just to give an idea that the elementary particles having spin half, they are on the one side, and those who are spin 1, they are on the other side. So the electron or muon or tau particles, they come under the category of the Fermi particles. And the neutrinos about which we are going to talk is also a fermion. So you can see the 3 generation. There is the electron, then we have got electron neutrino, then we have got a muon, then we have got a muon neutrino, then we have got a tau particle, and there is the tau neutrino. So in this way, the neutrino are categorized as the Fermi particle. Now, so broadly, we can have 3 groups of particles. One is called light particles, and as I explained to you earlier, they are called leptons. So lepton means very light particle. So there are 6 particles which are called lepton. So one is the electron, then one is a muon particle, and other is the T stand for tau particle, mu stand for muon particle, and E stand for the electron. Then they have got corresponding neutrinos. So mu stands for the neutrino, mu electron, E, then mu for muon neutrino, and tau for the muon. And so other particles, you can see there are a large number of particles exist, which comes under the intermediate mass. They are called meson, and very high particles, which are called barons. So now we come to the neutrino. So as I explained to you, neutrino is a very tiny particle with spin half. So particles having spin half or 3/2 or 5/2, they are called the fermions. So neutrino called fermion. The charge is 0, though we have got 6 types of neutrinos, but each one has got charge 0. So there is no charge. The mass of the neutrino is not well defined. So there is always a limit. So now the limit of the neutrino is, say, the very small mass, less than 2 electron volts. Actually, the mass also can be because the Einstein theory is equal to mc square. So E upon c square is equal to mass, we can say. So the 2 electron volt, there is a 2 electron volt upon c square, actually the mass unit. But normally it defines like in terms of electron volt. As electron mass is 0.511 MeV. So you can see the neutrino mass is extremely small, 2 electron volt, but it's a limit. Actually, mass defines, somebody says 0.1 electron volt, says 0.6. So there are many values which you can find literature. That's why we write only a limit, less than 2 electron volt, and they are considered close to 0. So it is designated by the symbol. So there are 2 types of neutrinos. One is called neutrino. So nu is the number or symbol used for defining, and other is the anti-neutrino. So anti-neutrino has got a bar on the nu letter. So nu letter is for neutrino, and anti-neutrino, nu letter is there, but there is a bar above it. So just to distinguish a neutrino from the anti-neutrino. So neutrinos are one of the most abundant particles in the universe, but very difficult to detect. So we'll find the reason why it is difficult to detect in due course of my talk. So very commonly we'll be talking about the neutrino or anti-neutrino. So the symbol nu and nu bar will identify the type of the neutrino. So before coming to neutrino, again we have to come back, or we have to take help of the particle which are associated with the neutrino. So again, lepton is what I just now explained. The leptons are the particles, and also we have got antiparticles. So universe has made particle and antiparticle pair for almost all the particles. So here we have got an electron. So when we say electron, it has got a negative charge. Then muon also got a negative charge, and tau particle also with a negative charge. So these particles are called particles. So electron, muon, and tau particle, there are 3 particles. They are only considered for my talk because they are relevant to the neutrinos. Other particles are there, but we'll not just now shown you the large number of particles, but we'll just concentrate only on 3 particles. So electron, muon, and tau particle, they are the particles. And our particle, they are leptons, and each has got a negative charge. So below, I have just given a chart now showing that each of these particles has an antiparticle, also called anti-lepton, with positive charge. So nature has made that the particle has got negative charge, but the antiparticle has got a positive charge. So for example, electron, the electron which we know, everybody knows electron, that has got a negative charge, but the opposite particle which we call as the antiparticle is a positron, has got a positive charge. Similarly, we have a muon. Muon has got a negative charge, but the anti-muon has got a positive charge. Similarly, we have a tau particle with a negative charge, then the anti-tau has got a positive charge. So nature has made all these particle, antiparticle. We don't know how these particles were made, but of course one can study. They're all detected, well studied in the laboratories. So as such, a number of pairs of particle, antiparticle exist in nature, but it's just an example because the neutrino are related with these 6 types of particles. So electron, positron, muon, antimuon, tau, and anti-tau. Now the basic discovery of the neutrino. So how the neutrino was discovered? It was discovered in 1930 by Pauli. So the neutrino was discovered during the beta decay. So there was experiment conducted in detecting the beta decay. So the beta decay is a particle. So neutron decays by emitting a beta particle and gets converted into proton. As I told you, the neutron and proton ratio changes by emission of a particle, beta minus or beta plus. So the neutron changes to a proton by emitting a beta particle. So you can see that proton is a positive charge and beta particle is a negative charge. So when proton and beta particle are together, the charge is 0 and neutron has got charge 0. But when it's split into 2 parts, so proton gets positive charge and beta particles has got negative charge. So earlier this was the proposed decay. But a scientist in 1930 had a concept of spin, and then the scientists objected that the neutron has got a spin half, proton has got spin half, and the beta particle has got spin half. Then how this decay is possible? Because as per quantum mechanics or basic theory of the particle, spin is conserved in all the nuclear reaction decay process. So this violates the basic principle of the spin. So scientists objected, and then Pauli, who was a great scientist of our universe, everybody knows about him, he thought that, yes, there is a mistake, or one has to add some new particle so that the spin can be conserved. And however, in this proposed process of neutron decay, the spin is not conserved. So left-hand side is not equal to right-hand side. So for the conservation of spin, a new particle called antineutrino, which spin half was proposed, and the decay of the neutron. So to conserve the spin equation, the particle was introduced, and the introduction of antineutrino could conserve the spin. And really interestingly, the antineutrino, so this is a bar is there, so it is the antineutrino, was given a spin of half. So neutrino is now when decays, it decays into a proton and a beta minus particle and then antineutrino. Now I have written a minus sign here because the spin is a vector. So if the beta particle has got spin in vertical direction, the antineutrino will spin in the downward direction. And therefore the spin will be 0. So beta spin can be compensated by neutrino spin, or proton spin can be compensated by the beta spin because they are added by a vector. And therefore, the left-hand side spin can be made equal to right-hand side. And that's how the antineutrino were discovered in the decay of the neutron. And now we know that the source of antineutrino is the neutron decay. That's why I explained earlier about the decay of the beta particle. So when we say antineutrino, it is coming from the decay of neutron. And of course, there are other nuclear reactions, they produce antineutrino, but it's the main source of the antineutrino. Now we come to neutrino. So just now, as I told you, there are 3 types of particle: electron, muon, and tau particle. So correspondingly, we have 3 types of neutrinos. So there are 3 types of neutrinos: electron neutrino, muon neutrino, and tau neutrino. So the electron neutrino, it is emitted with the beta particle, as just now explained to you. The electron, in 1930, Fermi discovered neutrinos in beta decay experiment, and a Nobel Prize was given in 1995 because the discovery was made late. So actually, it was discovered much earlier in the beta decay. Then there's a muon neutrino. The muon neutrino is emitted along with the particle called muon. It was discovered in 1962 and earned a Nobel Prize in 1988. So this got Nobel Prize earlier to electron neutrino, because the electron neutrino did not get prize directly. It was indirect prize but it is assigned to discovery of the electron neutrino. So both the electron neutrino and the muon neutrino fetched the Nobel Prize, and the tau neutrino is emitted along with the particle called tau particle, and this was discovered in 2000. Very recently it was detected, because the tau neutrinos are not very easy to produce or very easy to detect. But muon neutrino, electron neutrino are well studied. Not that level, tau neutrino is not studied in that way. But there's, of course, they exist. So now we have a information that there are three types of neutrinos: electron neutrino, muon neutrino, and tau neutrino. So for the practical application, when we look for the application for the neutrinos, then I think most of the application will be from the electron neutrinos, because I will just explain to you that the sources of electron neutrinos, both antineutrino and neutrino, are available to us very easily. But muon neutrino and tau neutrinos are not available so easily, or the number is not that large. So again, I will come the same way. The process of negative beta decay, so neutron changes to proton, a electron is emitted. Actually, electron and beta particle, they are same, and we have got antineutrino. So now the energy of the antineutrino is very important, because if we have to go for a device, to make a device, then what is the energy of the antineutrino? So I just wanted to just calculate and just show you how the energy of antineutrino is calculated in a particular decay process, which I will explain to you. So for example, I just taken one example only, just to calculate the energy of the antineutrino. So the energy spectrum of beta particle emitted by phosphorus 32 radioisotope. So there are many radioisotopes which emit beta particle, and any beta particle radioisotope you take, it is going to emit anti-neutrino, because beta particle, whenever beta particle is emitted, it is accompanied by the emission of the anti-neutrino. So that was known long back, and now it is very certified. Both beta particle and anti-neutrino are emitted simultaneously and share the disintegration energy of 1.71. So when the energy of this decay is calculated, the disintegration is 1.71. So I just given a plot here, the energy spectrum of beta particle, which can be measured in the laboratory very easily. So you can see that there is not a single energy of the beta particle. There is a spectrum of beta particle. So though the disintegration energy is 1.71 MeV, the beta particle does not carry all the energy, but it carries energy right from 0 to maximum 1.71 MeV. So this was again a surprise to the scientists, that why the beta particle is not carrying all the energy of the disintegration. But now it is known that the beta particle is not emitted alone, but is emitted along with the antineutrino. So I just given an equation that the energy spectrum of the beta particle emitted from phosphorus 32. So I just written an equation: phosphorus 32 decays to sulfur 32, beta particle, and the antineutrino, and the energy is 171.71 MeV. So it is very interesting that the disintegration energy 1.71 MeV is shared by the emitted antineutrino and the beta particle. So for example, so the energy 1.71 MeV is equal to energy of beta particle plus the energy of the antineutrino. So if the beta particle suppose the beta particle carries 1 MeV energy, then the antineutrino will have energy of 0.71 MeV. In case beta particle has an energy 0.37 MeV, then the neutrino will carry 1.4 MeV. So they share the energy. So sum of the energy of the emitted beta particle plus the energy of the antineutrino will be always equal to the disintegration energy of the reaction. So I've just taken an example of the phosphorus. One can have a different example. So from this plot, as we have got a plot of the beta particle, same plot will appear also for the antineutrino. And you can see that the antineutrino emitted will have a spectrum of energy, and the maximum energy of the antineutrino will be 1.71 MeV. So when the antineutrino carries 1.71 MeV energy, at that time, the beta particle energy will be 0. When the beta particle carries 1.71 energy, the neutrino will have 0 energy, and like that. So they share the energy. So that's why the neutrino energy, what we'll get from this process is not a one energy, but there will be a spectrum of energy. So the neutrinos which will get will have spectrum of energy, not a single energy. I will show you also the spectrum of energy. Now, similarly, so this we are talking about the anti-neutrino, which is a bar. So neutrino is new, but when there is a bar, we call it as anti-neutrino. So similarly, we have a neutrino. So the nature is really wonderful. There is also an equation for the neutrino. Here, a neutron is converted into a proton and the anti-neutron is emitted. In the case of neutrino, it is the reverse. A proton is converted into a neutrino. Then a positron is emitted because the proton has got a positive charge. Neutron has got a negative charge. To balance the charge, because the charge is also balanced in all the nuclear reaction decay. So a positron is emitted and the other particle emitted, which we call as a neutrino. So neutrino is also emitted. So this is again a reaction which we have for the emission of the neutrino. So whenever we have a neutrino on the earth or from any experiment, the main source can be a conversion of proton into a neutron. But of course, there are also other sources which I will explain to you. But the basic equation by which the neutrinos are produced is the proton converted into a neutron. So this is also called the beta decay. So both production of anti-neutrino by conversion of neutron to proton and emission of beta minus is called beta decay. Similarly, the conversion of proton into a neutron and emission of a positron is also called the beta decay. Both processes are beta decay. So this is an example of copper 64 converting into nickel 64. Now in this case, the proton has changed to neutron. Therefore, the copper has got 29 proton, whereas the nickel has got 28 proton. So one proton is converted into a neutron. So the mass number remains the same. So both copper and nickel, the sum of the proton number and neutron number is 64 only. But in case of copper, the proton number is 29, where in the case of nickel, the proton number is 28. And the result is emission of a positron and a neutrino. So the neutrino comes as a result of conversion of proton into a neutron, and we have got the positron. So we can also have the same spectrum for the positron emission as we have seen for the electron. So we have a spectrum in which the positron energy changes again because now in this case the neutrino shares the energy. So in this case the disintegration energy is 0.65 MeV. So neutrino and positron share the energy, and that's why we do not have a single energy of the positron, but there's a spectrum of positron. So same spectrum we can get for if we measure the neutrino, same type of spectrum we'll get for the neutrino, because the sum of the energy of the neutrino and positron will be equal to 0.653 MeV. But the detection of neutrino is very difficult, and that's why we cannot have such kind of plot in the laboratory just to demonstrate the energy of the neutrino. But we have to depend only on the plot of positron, and we conclude that the neutrino also will have the same plot for if we measure the neutrino energy, but we cannot measure neutrino energy in this way. So just this is showing the same thing, that the neutron changes to proton emitting antineutrino, whereas the proton changes to neutron emitting a neutrino. So we have a source of antineutrino and neutrino by just conversion of this. But in addition, there are also other sources which we should discuss about it. But this is the antineutrino is of course a source which comes from the conversion of a neutron to a proton. So this is again a summary of this, that a beta minus particle emitted, the carbon 14 changes to nitrogen 14, and antineutrino is emitted, and the electron minus electron will be emitted, and carbon 10 emits a positron, converted carbon gets converted to boron 10, a neutrino is emitted, and a positron. So positron, neutrino, and electron, antineutrino. These are the equations which we have got. Now, there is a very interesting thing, that how to distinguish between the neutrino and antineutrino. So far, experimentally, there is no evidence, but only the spin of the neutron and antineutrino have been measured. So I have just given a diagram. So in case of neutrino, when it move in a given direction, the spin of the neutrino in opposite direction to the direction of its motion. Also, I had drawn the momentum as a direction of motion, and the spin is opposite direction. So neutrino has got left-hand spin, we can call, or we can, in brief, we can say that the spin of the neutrino in the opposite direction to its motion. Whereas in case of antineutrino, the spin direction and the motion direction, they are in the same direction. So far, as per our knowledge, based on this spin only, we distinguish between the neutrino and antineutrino based on the spin. So again, I will repeat, in the case of neutrino, the direction of momentum and spin, they are in opposite direction. Where in the case of antineutrino, the direction of spin and momentum, they are same. So this is the difference. If somebody asks me what is the difference between neutrino and antineutrino, of course, they are different in the case of nuclear reaction, which you can definitely find a difference. But just for difference, so the spin is one of the main criteria for defining the neutrino and antineutrino. Now, I will repeat again, there are three types of neutrinos which we have just now seen. So one is called electron neutrino, about which we have just now discussed. So electron neutrino, we got two types of, one is neutrino and again antineutrino. Then we got muon neutrino. Again, we got muon neutrino, antineutrino. Then we got tau neutrino. Again, we got neutrino, antineutrino. So the electron neutrino, muon neutrino, and tau neutrino, which we have just now seen already. So this is a brief summary of the neutrino, that electron neutrino, muon neutrino, and tau neutrino. And then they got antineutrino. So electron antineutrino, we got a mu e and we got a bar. Muon neutrino, and again muon neutrino, the mu is subscript and there is a bar on mu. Then tau neutrino, there is subscript for mu and there is a bar. So we got three types of neutrinos and three types of antineutrino. So you got 6 types of antineutrino. But as I told you, for the application, for the device application, we will be using only electron neutrino or electron antineutrino. The muon neutrino and muon antineutrino or tau neutrino, they are not, number is very small and the flux is also not continuous. So we cannot depend on these neutrinos, though they exist on the earth. But there is a lot of information available about the electron neutrino, and the flux is also very large, about which I will just tell you. Now the formation of muon neutrino, because somebody may be interested how the muon neutrinos are produced. So the muon neutrinos, which we say μe, is emitted in the decay process of negative muon particle. So muon antineutrino is emitted in the decay process of positive muon particle. So I just given 2 equations. So muon is a particle, muon negative means negative muon particle. It decays into electron and a muon, a neutrino and electron neutrino. So as I told you, the electron neutrino also is emitted along with the muon neutrino, whereas the positive muon particle decays into a positron and a electron neutrino and antineutrino, muon antineutrino. So there is a bar. So this is a major source of the emission of the antineutrino. Similarly, the tau neutrino was discovered during 2000 in USA by irradiating a target with 800 GeV proton. So this is very difficult experiment was carried out, but they detected very recently 2000, though it was only predicted earlier, but they could see the muon particle, that is new tau, that is the tau particle, and tau antineutrino, tau antineutrino. So you can see in the graph below. So they produce first the tau particle, then from tau particle, the muon tau neutrino is emitted. So both tau neutrino and tau antineutrino were produced and detected by nuclear reaction. So this is not the process of decay which we normally see. There are, of course, decays are there, but experimentally they have verified the presence of the tau neutrino and tau antineutrino. So this is the summary of the neutrinos, 6 types of neutrinos, their properties and they are produced. So the tau neutrinos, this is the basic principle, because here you can see they have produced first tau neutrino and then tau neutrino decays into the tau antineutrino. So this is the tau particle is there. It decays into a tau neutrino and the muon and the muon antineutrino. So this is the basic. There are many this kind of equations are there in nuclear physics. So this is the way one can create a neutrino in the laboratory. First, you have to produce the tau particle, then it will decay, giving you this tau neutrino. So this is way one can produce it. Now we'll come to the origin of the 3 types of neutrinos. So again, we'll come to the origin. So I told you muon neutrinos, tau neutrinos are not abundant in the universe, but we'll just touch the topic. But we'll focus on the electron neutrinos and the electron antineutrinos. So the electron neutrinos are produced in the core of sun through fusion reaction that earlier Dr. Bhatkar has already explained very nicely. And similarly, the electron antineutrino, the electron neutrinos are produced in the nuclear reactor. This is why I told you that we have got abundance of neutrinos and antineutrinos on the earth. So sun is a major source of neutrinos. So please differentiate between neutrinos and antineutrinos. Sun is a source of neutrinos, whereas the nuclear reactors are the source of antineutrinos. Whereas the muon neutrinos and muon antineutrinos, they are produced in the decay of muon particle and also atmosphere through the nuclear reaction. I'll give an example how muon neutrinos are produced. And tau neutrinos, they are anti-neutrinos. So they are again produced in the decay of tau particles and also through nuclear reaction in atmosphere. But we'll focus only on electron neutrinos and electron antineutrinos. So the electron neutrinos and antineutrinos, the electron neutrinos are generated also in supernova. And this I will explain to you in brief because most of you may be knowing about it. Then the electron neutrinos are generated inside the core of the sun. So because I will now concentrate on electron neutrinos and antineutrinos, so I just repeating same thing again. Then antineutrinos are emitted from the nuclear reactor. We'll just explain that. And muon neutrinos are produced by cosmic rays in the atmosphere. So the supernova we know because I just written here, the neutrinos are generated in the supernova. So supernova, of course, there's a big physics behind that. We'll not go into details of that. But supernova of a star, more than 10 times size of a sun, may leave behind the densest object. So what eventually the star, which is a very big star, 10 times the size of the sun. So it decays with time. So I will just go to it. Just briefly, I will explain to you. So the supernova star, more than 10 times of size of sun. So the massive stars are very massive. But they again have the hydrogen as a gas in them. Then slowly, they decay and finally they come to a element which we know is the Fe in the core. And finally, the Fe, the core, the protons are again converted to neutrons and we get the antineutrino. So this is just a diagram showing that the neutrinos and antineutrinos are produced by the supernova. So this is because of the conversion of hydrogen to Fe. Finally, the Fe is produced by fusion reaction and it is a collapse of the iron core in just a half second. So finally, the iron core is produced and that also collapses by emitting neutrinos and antineutrinos. And finally, the neutron is left. So we call it as a neutron star. So you can see this is the way a star collapses. So earlier, the outer surface converts into, due to fusion reaction, converts into helium. then helium converts into carbon, carbon into oxygen, oxygen silicon, silicon into Fe. Then finally Fe is left. But the years is very important. The star life is very large. To take the time for conversion of hydrogen to helium, it takes 10 to the power 6 years. Time of conversion of helium to carbon, 10 to the power 5 years. Carbon to oxygen, 600 years. Oxygen to silicon, 6 months. Silicon to Fe, 1 day. And core collapse in 1/4 of a second. So it's a large time. But finally, the star which we see in the sky, they are actually made of the hydrogen. But slowly, they get converted into Fe, and finally they collapse. And as I have written here, that finally when they collapse, the final core is Fe. Then Fe core also collapse to only neutron by emitting the neutrino and the antineutrino. And that's why we say that the supernova is a source of the neutrino. So this is the same thing again. The 10m is the mass of a star. And this is the hydrogen, helium, carbon, same thing. Then finally iron is there. Then the iron core collapse. And then we get the neutrino. So this is the same thing again. Hydrogen burning 10 million years, helium burning 1 million years, carbon burning 100,000 years, oxygen burning 1 year, and silicon burning 1 week. And then Fe only 1/4 second. So that's why we get the neutrinos. This is a source of neutrino supernova. So finally, when star collapse, that finally ends into a neutron star, and at that time we get the emission of the neutrinos from it, and neutron and neutrino. So this is one of the source of this. Now, electron neutrinos from the fusion reaction inside a star. So they are the same thing which I have explained to you. So due to fusion process, hydrogen is converted into helium and eventually into helium into carbon. So as soon as carbon core forms, it begins to contract, heats up until fusion carbon to oxygen. So an oxygen core then forms and contracts into heat and turns until it starts fusing into a neon. And this continues and turns into magnesium ion. So why this collapse? So this is the final picture, that we have a neutrinos coming from it. So hot neutrinos are coming from the core of the star finally. So we have a process by which the neutrino interact with the proton interact. So all these processes takes place. So this is just an example. So we have a source of neutrinos from the star. Now, the very interestingly, why star collapse, I will just explain very easily here. Then the core, when the star is there, why the star is not collapsing? Because there is a large mass of the star. So it has a large gravity. So there is a green arrows, they are gravity force. But the core is burning. A lot of energy is produced in the core of the star, and that gives the force outside. And that's why the star live for so many years. But when the energy produced in the core decreases slowly, then gravity overtakes the core energy produced because energy is decreasing. And finally, the star collapses. So it's a very interesting explanation. I like this very much, that the gravity finally overcomes and the star gets collapsed. So this is the spectrum of the neutrinos coming from the supernova. So you can see that the spectrum is the energy of the neutrinos coming out is very large, around 10 to 20 MeV peak energy. You can see here the number of neutrons are not much, only 4,000 per centimeter square. But the energy of the neutrino is very large as compared to what we get from the sun. But this energy peak is around 20 MeV for the neutrinos. So as I told you, we are also interested in energy. So there is again a spectrum of the neutrinos. So as I told you, that we always get to this is theoretically produce the spectrum of the neutrinos. So electron neutrinos from the sun. Dr. Amelekar, how much time I got now? Time, how much time? Time, how much?
Sir, go ahead. No problem.
I think
Okay.
yes, you can go ahead for a couple of minutes.
15 minutes, around 15 minutes. Okay.
Probably, yes. I think we are finishing within the schedule. So probably you can
Okay.
take 15 minutes.
Okay. 15 minutes. Okay. So neutrons also, how I will explain you how the neutrinos are coming from the sun. So I just given a small picture showing that the neutrinos are emitted from the sun and they are coming to Earth. So the neutrinos directly are emitted from the sun and they are having the. So what is the reason? So after detection of the neutrinos on the Earth, it was concluded that the source of tremendous energy of the sun is due to proton-proton fusion reaction. So now everybody knows about this. So I will not go in detail. So the actually proton means the hydrogen. I have written hydrogen instead of proton here. So proton produce deuterium and the emission of neutrino. Then the here deuterium converts into helium. Helium again converts into. So again we have got a neutrino. So you can see that all this fusion reaction, the hydrogen goes up to boron. I have just written up to boron. But in the case of supernova, it goes up to supernova also. Same type of reaction, fusion reaction occur in supernova also, but it goes up to Fe because the energy is very large. In the sun, we have up to boron and some, of course, there are also a nucleus, higher mass number nucleus are produced, but I just written up to boron. So you can see that each reaction is emitting a neutrino. And therefore, the neutrino is a source. The sun becomes a source of neutrino. It produces energy as well as it is also producing. So this is a brief description how the neutrinos are produced in the sun. So the time required for neutrinos is very interesting. There is time required for neutrinos to travel from sun to Earth's surface. Now, the neutrinos travel with the velocity of light. Light and neutrino velocity is almost same. So neutrinos produced and emitted from the core of the sun travel with the speed of light. So you can see the sun diameter. So however, due to large size of the core of the sun, neutrino take about 2 seconds to travel from the core to surface of the sun, covering a distance of 6,000 kilometers. So 600,000 kilometers is the diameter radius of the sun. So neutrino takes so much, only 2 seconds. Whereas after exiting the surface of the sun, the neutrinos travel from the earth to the earth, for which neutrino takes about 480 seconds. So when the neutrino is produced on the sun, it takes 480 seconds to come to the earth, though they are traveling with the velocity of light. So you can see the distance between some. So in brief, the sun is a very strong source of the neutrino on the earth. So this is again about 3% of the total energy radiated from the sun is in the form of the neutrinos. So the flux of neutrinos at the surface of the sun is of the order of 10 to the power 11 neutrinos per centimeter square per second. So this is very important from the point of view of device making. So now I'm sitting here, you are sitting there. So all of us get exposed to neutrinos because neutrinos can travel through any medium. They have got least interacting, very low interaction cross section. So 10 to the power 11 neutrinos per square centimeter per second are incident on the earth and of course on our body. So the cross section of interaction of neutrino with matter is extremely small, and therefore it is very difficult to detect neutrinos. Now, for example, as per the rough estimate, out of 10 to the power 14 neutrinos incident on the Earth's surface, only one neutrino interacts with the atom existing on the Earth. So if 10 to the power 14 neutrinos fall, only one atom will give response. So if 10 to the power 11 are coming, then only 10 to the power -3 atoms will give response per second. So the cross section is extremely small for the neutrino because they are not interacting. So this is again the same thing. Neutrino flux coming on the Earth 10 to the power 11 neutron. Energy of neutrinos from the sun is in the range of 400 kV to 18 kV. So this is the energy range of the neutrinos. As I told you, neutrino does not have a single energy. So there's a spectrum of energies, and that will vary from 400 kV to 18 MeV. So this is again a plot of the spectrum of the neutrinos. So 10 to the power 11 neutrinos energy from say -1 to 8 MeV. Then the different spectrum is given. So up to 18 MeV energy is available from the sun. The low energy neutrinos are more in number as compared to high energy neutrinos. So this is again a plotted, theoretically modeled plot for the neutrinos coming from the sun. Now the antineutrinos from the reactor. Now the nuclear reactor, as we have got large number of nuclear reactors in the country, all over the world we have got. So the reactors is a source of antineutrinos. Because the reason which I have just now explained, the neutron is converted into a proton, emitting an electron, the beta particle, and the antineutrino. So fission fragment, because the nuclear reaction works on the basis of the fission fragment. And therefore, uranium-235 is a main source for the reaction in the reaction, the fission in the nuclear reactor. And it leads to formation of the neutron converted into proton. So this is just an example of the fission. The uranium is fissioned by absorption of a neutron. Then we got fission fragment. There are two parts are produced by fission by breaking. And these fission fragments are highly beta emittive. So you can see the graph here. The two fission fragments I have shown, and each fission fragment decays by beta emission. So if there is a beta emission, it is accompanied by the antineutrino. And therefore, we have a big source of antineutrino from a reactor. So the antineutrinos produced in the nuclear reactor come out of the reactor shielding wall and building and travel in all directions. So the beta particles and everything is radiation are absorbed or are shielded in the reactor core. The big reactor core, more than 20 feet thickness of the reactor core. But the neutrinos cannot be stopped because their cross section is very small. And all the surrounding buildings, trees, houses, etc., as well as persons working in and around the nuclear reactor, therefore, get exposed to antineutrinos having a flux of 10 to the power 10 neutrinos per second. So if you are going or visiting a nuclear reactor, you are bound to get exposed to 10 to the power 10 neutrinos per second. But nothing happens to you because they don't interact with the body or they are uninteractive. However, the cross-section of reaction neutrino with that is extremely small. Therefore, neutrinos do not induce any damage to human body. So all those working in nuclear reactor or office of the reactor or even 10 kilometers away from reactor, the neutrinos will be falling on them. So the antineutrinos are emitted from reactor. So this is an example that the reactor, you got large number of neutrinos coming from it. So just I have given an example that whenever there is a reactor, the antineutrinos are coming. So this is the cartoon showing that if you are near a reactor, a person or anybody, even if you are in the plane, you get exposed to neutrinos. If you are in the car, you get exposed to antineutrinos. So this is a cartoon showing that you cannot escape your spell by not getting exposed to antineutrinos. So antineutrinos are around everywhere, particularly near the reactor region. So these are the spectrum of the energy of the antineutrinos coming from the reactor. So the energy is around 9 MeV maximum energy, but low energy neutrinos are large as compared to low. So this is the spectrum of the neutrinos coming from them. So source of muon neutrinos. So muon neutrinos are produced in the upper atmosphere by cosmic radiation. So these are the reaction for producing muon neutrinos, muon antineutrino, muon neutrinos. So they are a decay from the pions. So we'll not go into details of that, but they are producing this. So you can see there is a shower by which the neutrinos of muon neutrinos are produced in the atmosphere. So these are a picture showing how the muon neutrinos are produced. So cosmic radiation, the proton will produce pions here, and the pion will decay into the muon neutrinos or muon antineutrinos. So this is the way muon neutrinos are produced. And again, when you go, say, for a trip or anywhere around, you are going to get exposed to muon neutrinos also, because all cosmic radiation coming on the Earth, they are accompanied by the muon neutrinos, star neutrinos, neutrinos, antineutrinos. So everybody is getting exposed to, even now we are in baby seminar, we are getting exposed to neutrinos from the sun. So interaction of neutrinos. So the three types of neutrinos are classified as electron, neutron, neutrinos. There are large number of these types of neutrinos moving around us all the time. So trillions of neutrinos are passing through our body every second. However, we do not feel because cross-section of interaction of any neutrinos is very small. So for example, neutrinos can travel through the mountain because they are not interacting with the body. So mountain, earth, even if the earth, the neutrino come from sun, they pass through earth and goes on other side. So I'll just take a very small time for detection of neutrinos because the historical is very important. So detection of antineutrino. So the detection of neutrino antineutrino is very difficult because they have extremely small interaction cross section. But for first time during actually 1953 detected, but it was announced in 1956 the discovery of the detection of the antineutrino. And so the experiment was carried out using this reaction. So this reaction is very important. So Kovan's resin detected electron neutrino from a nuclear reactor in 53, but they announced their discovery in 56. So what they did, the antineutrino from reactor, it was bombarded on water because water contains proton, means hydrogen, and then a positron is emitted and neutron is emitted. So we can, because the positron annihilates, giving two gamma rays, so they could measure the gamma rays from the positron, and neutron is absorbed in a cadmium solution, and that's why they confirm that the antineutrinos were detected. So these major cross sections of nucleo was 10 to the power minus 44 centimeters square. The unit of nuclear reaction cross section is, so the reaction cross section normally we call as a barn as the nuclear cross section 10 to the power minus 24 centimeters square, and is considered to be very high because nuclear reaction cross sections are normally low. But the neutrino or antineutrino cross section with matter interaction cross section is observed 10 to the power minus 44 centimeters square. So you can just imagine how low is the cross section. But even then, they could detect this antineutrino from there. So this is just experimental situation here. So the antineutrinos are coming from the reactor. Just now we have seen that the antineutrinos is source from reactor, and the water was kept and it was dissolved in cadmium chloride. So the antineutrino coming from reactor interacted with the proton and emitting a positron and a neutron. So the positron produces, it's called annihilation process, and it produces two gamma rays, so which written as the annihilation gamma rays, and the neutron gets absorbed by cadmium, and the cadmium gamma rays were measured. So this was the first discovery of the neutrino. So I just shown you the cadmium. So this was the first time they measured the 0.5 eV gamma rays arrived first time, and then the 10 microsecond the gamma rays from cadmium arrived. So this was the classical experiment, and this got the Nobel Prize for the detection of neutrino for the first time. Though they are detected long back, but the Nobel Prize is given after that. In addition to sun, neutrons are also emitted by supernova, which I just not discussed. So I'll just take only 5 minutes just to give you an idea how the neutron detectors are made in the around the world. So number of countries have developed detectors for detection of flux of electron neutrinos inside the earth, on the earth. So cross-section of interaction neutrinos with the matter is extremely small and the medium is extremely large. So what they've done in USA, a detector, there are many detectors, but just this is a famous detector. So their detectors are called Homestake detector in USA. So detector is in the form of a stainless steel tank located because they want to avoid the interference from the cosmic radiation. They keep detector below the Earth's surface around 1,000 meter down. So this was around 1,470 meter in the underground. So tank is filled with 380 cubic meter volume of perchloroethylene fluid, which contains 10 to the power 30 atoms of chlorine 30. So this is a reaction. The Homestake detector, they wanted to, so this is underground in a tunnel. So the concept is that the neutrino from the sun, they will fall on the chlorine and they will produce argon 37 electron. So the argon was with a radioactive material. So after exposure, they take out the argon from the material, from the liquid, and then they calculate the number of neutrinos coming on the Earth. So this is a classical experiment, and the detector is very successfully working. So the argon 40 is the stable, but argon 37 is unstable. So they take out the argon 37 from the liquid and then count how many neutrinos have fallen down today during the experiment. Similarly, there is another detector in Japan, which is called super. So this is also a very recently built detector. So this is again based on the detector, they have used again the water here but the concept here is different. They use Cherenkov radiation here for the detection. So this is again an underground detector in the fusion detector. So the working detector works on the principle of Cherenkov radiation, in which a cone of light is produced by moving electron. So the energetic MeV neutrinos after entering the detector can transfer energy to electron in water. And then if the electron that moves faster than light in the water, because as you know, the light in the water does not travel with the velocity in the what they have got in vacuum, but the velocity decreases. Whereas the electron can move faster than the light. And that's why this is a very interesting thing that it produces a cone of light in the system. So when electron moves, so neutrinos interact with the electrons, nuclear water can produce. So this is just a definition of the velocity of light, and velocity of light is 10 to the power 8, whereas so light water traveling at the velocity of 2.2 km, which is 3/4 of the speed of the light in vacuum. So the velocity decreases of light in water, whereas the velocity of electron can be more than the velocity of light. As a result, they produce a cone of light. So this is called Cherenkov radiation. So whenever there is a particle moving in a medium with the velocity more than velocity of light, then there is a radiations are emitted, which are called Cherenkov radiation. So it also got Nobel Prize, Cherenkov radiation. So the concept here is that the muon or electron, neutrino, or muon, when electron neutrino comes, it will produce 2-3 cones of the Cherenkov radiation. Where if the muon is there, there is only single cone. And this was detected. So they have put water. This is all filled with the water. And you can see the photomultipliers are placed there, and the photomultipliers could detect. So you can see the light coming from the neutrinos, and they're falling on the photomultiplier. So this is a working model for the neutron detector in Japan. And there many laboratories have been using this facility. I also visited this facility in Japan. It's a very interesting detector system. Long back, it is away from this main city. So neutrino oscillations, of course, I will not talk about it, but only just for information, I will tell you that just now we have said that there are 3 types of neutrino: electron neutrino, muon neutrino, and tau neutrino. And sun gives electron neutrino. So what scientists have done, they have calculated the number of neutrinos emitted from the sun. But what they found, that the number of neutrinos which these detectors already detected, these 2-3 detectors, they found that the number of neutrinos coming on the Earth is not same as the neutrino emitted by the sun. So they were puzzled. Why this is happening? Why the neutrinos emitted by sun, why they are not coming to Earth? Because they can penetrate the atmosphere without any problem. Then it was concluded that the electron neutrino, while coming to Earth, get converted into a muon neutrino. And muon neutrino also get converted to tau neutrino. So this is called electron neutrino oscillation. So this is, of course, this is just an example that while coming from sun to Earth, the electron neutrino converted into muon neutrino converted into tau neutrino, and so they go on. So I just shown a figure here. So this is called neutrino oscillation. So this is a very recent topic for research in the nuclear physics. Why it is this, and there are many theories proposed, and then there are laboratories that are measuring the. So thank you very much for listening to me. Thank you.
Thanks, Professor Boraskar, for teaching us the basics of neutrino physics. which anyway will be very important for all of us to understand the interactions of neutrino with the nanomaterial, nanostructured metamaterial used in the neutrino voltaic devices. Anyway, once you come back to India, you are just staying opposite to CIMET. We would like
Yes,
to have
definitely.
more interactions with you. And
Definitely.
also with Professor Mrs. Boraskar, incidentally,
Yes, yes.
also a professor of solid state physics. Probably can
Yes.
you see Professor Mrs. Boraskar?
Yes,
Yeah.
yes, she's
Yes, hello.
For the
So it will
positive
be really
time,
interesting.
yeah, for the positive time, we will not have questions at the moment, and
yes,
switch over to next seminar by Dr.
okay.
Ludwig from New Energy Technology, Germany. Dr. Ludwig has obtained diploma in physics from the Technical University of Berlin 2001 and a Doctor of Natural Science degree from the same university in 2005, both with highest excellence. Since 2006, Dr. Ludwig works as an independent researcher and consultant for the new energy projects and was deeply involved in the projects in countries like Germany, Turkey, India, Qatar, and Mexico. He measured energy efficiencies, designed and implemented research projects, and helped in developing promising technologies. In the specific context of the webinar theme, he has been conducting experiments in quantum field effect and their use for new energy technologies. He's studying the Casimir effect in his laboratory. For this experiment, he uses state-of-the-art nanopositioning, an atomic force microscope, and vacuum equipment to make use of a change in quantum field background radiation. He recently expanded the AFM, that is atomic force microscope, used for magnetic force microscopy and to study the fundamentals of magnetism and its connection to quantum field radiation. Dr. Ludwig has participated in a large number of international conferences on fusion energy. May I request Dr. Ludwig to deliver his speech, please? Dr. Ludwig, please.
Yes, thank you. So first, let me also say thank you for inviting me to give this speech in this very interesting webinar. So I'll try to share my screen here. Let me see if that will work. So we'll have to wait a second till the machine here processes this demand. I hope you can see the picture now. Takes a few seconds here. So I like to take all of us through a little journey. First, I'll give
Professor Ludwig, can you start your presentation, please? Is there any problem, Professor Ludwig?
Sir, he has lost his connection. Hope he will
Come back. He'll
be
come
back.
Okay, we'll wait for that.
Yeah. Meanwhile, if somebody wants to ask questions, you can ask.
To Dr. I think Dr. Holger and Dr. Bhatkar probably can interact with Professor Boraskar in the meantime. So, can you unmute Dr. Holger? And if you have some questions to Professor Boraskar.
Yes. So thank you very much, Dr. Boraskar. This was very interesting, and I like this kind of passion of these basic researchers, because the basic research of the neutrino is something what fascinating me. And but the neutrino under the astrophysical aspect is something I needed a couple of time to find my peace with this point of view. I tell you why. This explanation for the neutrino, what we have today, is a history of knowledge, what has changed all the time. So at the beginning, a couple of 100 years ago, the neutrino was something what nothing exists. It was a postulation only, because in the physics, it was obvious that this, under the mathematical aspect, it doesn't work. There must be a little piece of energy, it was lost. And so the neutrino was postulated. And there are many, many famous scientists donated by the Nobel Prize of Physics within the last decades always find out something new. And this is a big history. I saw the history about neutrino physics. I saw it published just a couple of days ago. It's 90 years of neutrino physics already. And in this 90 years, many findings were, this neutrino physics, I like to tell it, is today, under my opinion, the hottest topic in physics at all. So in this kind of physics, we find many answers. We will find all the answers what we need. And so I'm so happy that you have explained it so from the roots today. So you explain it from the roots. And under my opinion, we will not have catched all this, within the years, the detectors become smaller. The University of Chicago now has detectors which are like small, like size of a small machine only. And I like to make my personal peace with the basic researchers, because at the beginning, the basic researchers were attacking us. They were attacking us, and they say, oh, they want to catch the neutrinos with foils. We doesn't want to catch the neutrinos by foils. We have, and we can't tell exactly today how much energy, what is the converted energy, is a more neutrino or tau neutrino or whatever. So we doesn't catch neutrinos. And neutrino will take technology as to take a little kinetic part of the energy, not by catching, but by using, by converting. And so I think, and I'm sure within the next years, there will be coming a lot of more findings. And so thank you very much for explaining. And now I see Dr. Ludwig is again online, and hopefully you will continue soon. Thank you very much, sir.
Yeah, thank you, Holger, for jumping in. I hope everybody can hear me now again.
Yeah.
Somehow the connection broke, and I'm afraid it has to do with trying to share my screen. So I will not show you any pictures. because I'm afraid the same thing will happen again. And so I think we will find another way, maybe later on, to share some pictures. So I will give my my little talk without pictures. So the new energy technology is it started many years ago. One of my heroes of that scene is Nikola Tesla, because he didn't just invent the AC current that we all use and all the electricity, but he researched a lot in his like from 1900 to 1930. He researched, found a way to harness energy from the environment, and his vision was that we will connect to nature, and he was very sure, and he demonstrated it, and he was way ahead of his time. And not only did he detect vibrations in the Earth's atmosphere that were named and detected later as Schumann resonances 50 years later, but he also talked about particles that, from our point today, most likely are neutrinos. So since the days of Nikola Tesla, where there were a number of people like Morey and others who invented and showed very interesting machines. And so my personal part in this journey is, as was mentioned, to measure efficiencies, and which is kind of a topic on its own. So can't show you a picture here, but to start with the neutrino group foil, it's very interesting that they can actually demonstrate their foil. I've seen it in a conference, but also there's video out in the internet that you can look at. And so they have this foil that's about the level that has been demonstrated. And if you stack the foil, more energy comes out. And also what they have done is they went to a notary and demonstrated it there. So there's like a protocol and a calculation how much energy came out. And of course, they published their patent application. So an important point for me to make as an expert in this field is that it is a very promising technology, because they actually demonstrated it, that it works. Plus, they give a lot of information on how it works. So I want to pick two parts on the physics around how this foil most likely will work. So first, the connection to the neutrinos. So there is a paper from China, from a researcher called Wang, and he published on graphene, neutrino mass, and oscillations. So we just heard in the previous talk that the neutrinos oscillate between the three different types. So in a similar way, if you have different graphene layers, These graphene layers interact with each other in a very similar way, or in the same way as the neutrinos oscillate. So if you read the paper from Zhongyu Wang, you will see how that interaction will actually work. And so here I see, and as far as I know, this is part of the reason why the whole foil is called neutrino energy foil, because of this connection that the neutrinos interact and oscillate into the and with the graphene layer. Now, the other, maybe even more interesting part on this graphene is the sandwich between the silicon, the two silicon layers, and the graphene layer. So as an example, the University of Arkansas, and the researcher, which I have nice pictures from, but you can go on the internet and look at them. So Paul Tihabo from the University of Arkansas, he demonstrated, as others, that the graphene in the silicon sandwich starts to oscillate. So Holger also explained that this is part of the harnessing process. So the radiation, the neutrinos, and other energies around, for example, ambient heat, most likely, they make the graphene oscillate, and this oscillation can be converted into electron flow, meaning current. And I don't have a picture to show this. I have a picture, but I can't show you the picture right now. But there's even a little movie clip out. So this oscillation, which several researchers have discovered and studied and are studying, this leads to the current of from the neutrino foil. Now, as I hope we in this whole research will come further, is there's a lot of possibilities on the material side, on this metamaterial side, like the doping, the combination, exactly on how the graphene is treated, and the silicon, as we know from semiconductors, is also very important, how you dope it. So, and if you think how far we went from the first silicon transistor, I think I even have a nice picture of it, is and now we are at the computer level, computer chips, much more sophisticated. So if you look at the neutrino device and it's demonstrated, it's more on the level of the first transistor with gross materials connected, but it worked and it showed the principle. So the same here on the material side, there's a lot of possibilities. Now, as you can hear, that's also part of my education was semiconductor physics. So as a scientist, my work mostly is now evaluating prototypes or trying to develop them. So here the neutrino group has a foil. So of course, what I would like to do is to measure them. So the hope is that in the near future, we will have more of this foil, so we can actually build larger devices and not just show that the semiconductor is a calculator is working, but that you can power small devices from this. So I'm a very big friend of showing that things work by demonstrating that you can power things with them. That's you don't need much proof or calculation if you can power a flashlight or a mobile phone. See, so one thing I hope is that more foil comes out so we can make more experiments with them. On the scientific side, like I said, the materials are important, and there's a big field on the materials, but also on the fundamental question, where does the energy exactly come from, usually is helpful in enhancing the effect if you know exactly what's going on. So here we also need more foil, because on the efficiency side, if you can have more power, then it will be more easy to detect where is this power actually coming from. So what part of the radiation or ambient heat or neutrinos, what is exactly giving out the power? If we have like a watt or 2 watts, then it's quite easy. You can use um, easy to build but sophisticated calorimetry to see how much ambient heat is going in. You can see the radiation parts. You can exclude certain vibrations, not the neutrinos. They just flow through. So as a scientist, of course, that's always interesting, but I think also for developing the whole process, it's helpful to see what exactly is going on. But first, we need more foil to actually build larger devices to answer these questions. I think on a single foil, it will be very difficult. So it's, if you power a calculator, it's not enough power to actually differentiate where the power is coming from. Because, for example, if it would be ambient heat, the amount of energy is so small that you don't really, it's not really possible to detect it. It's very, very difficult. But if you use like a watt or 10 watt or kilowatt, then you will definitely know quickly where is the energy coming from. If it's ambient heat, if you take a kilowatt of ambient heat, then you have a nice cooling machine, which will be very popular in India. You don't even need to power anything; just the cooling will be the thing to sell. So that's an interesting question. So let me see what are the other interesting questions. So yes, so we need larger prototypes. Then, of course, and I know that's part of the whole deal here, is you need replications. I mean, if other people can do the foil, then it's a very important part of the scientific and process that it can be replicated. And I already said that refining the materials is a very important road here. And so the aim is to have more energy density. That the energy density, theoretically, meaning on a single foil, is already very high. That has been demonstrated. But I know that if you stack them up and make it larger, you will already discover, or you will usually discover, that you need to refine the materials in order to make them work for like a car or something like this. Because we don't know what happens if you stack up so many and you build a whole car of it. Yeah, but that's down the road. So and further down the road, I hope that the Neutrino group manages, or all of us manage, to get to product level devices where you can actually, people can actually go around using these things. Because if something is useful, usually nobody asks how it works. I mean, who knows how a television works or a mobile phone? I mean, if you, yes, among our crowd, probably everybody can tell how it works. But if you go to a shopping mall or somebody and ask 100 people who just bought a mobile phone, I don't think anybody can tell you anything about any detail. So I think that this promising technology if it is in many things, for example, a mobile phone, obviously, as Professor Bhatkar said, it's everybody will have one, everyone will carry one around. So if it will be powered by a little neutrino foil module, then it will be a new age. I mean, it will be, everybody will know that this technology works. And yeah, and so that's the aim of it. So I don't know if I've covered everything. I made it a bit shorter, I guess, because there are no pictures. So yeah, if I have a few more minutes, I think here in this crowd, the metamaterials and actually how to make it for your institute is probably the most important part. For the other scientists, probably the vibrations of the graphene foil and how that mechanism actually captures energy is the core of the scientific question here. But I hope we can answer and discuss and experiment with this as we have more foil. So I wish the whole project a very big success, and hope we can have more webinars and also have practical, because actually I'm not a theorist. I like hands-on building, measuring, and that was already been said. That's what I usually do with nanomaterials and the vacuum state that Professor Bhatkar says. That's also part of my my research to actually see how much energy is all around us. And another part that wasn't mentioned, I also research into consciousness, not just as a yogi with meditation and silence, which is very important and very helpful in progressing into these new fields, but also practically how thoughts interact with matter. So, and with single quantum events. So that's also a part that hasn't been mentioned. And I think that if we have the neutrino foil, that will also become apparent that it might work differently for different people or in different environments, in different mental environments. Like in peace, it might give more energy than in a very harsh environment. And I know also that Holger is very much for applying these new technologies for peaceful applications. So yes, there is a subtle effect of thoughts on matter, but there's also a very gross effect on how we use things. And I think if we have access to new large amounts of energy, it's even more important than it is used, that it will be used for peaceful applications and not for weapons and tanks and all of this. But, and that is also a question of consciousness among us, that we create a peaceful environment and that peace emanates through everything, and that we protect this nice new development that will be used for peaceful applications. So that's my speech. So I'm open for questions or discussions. Thank you very much.
Thanks, Dr. Ludwig. Uh, we are looking forward to have more interactions with you in person whenever you come to India. Once the COVID pandemic is under control in India, because
Yes.
of vaccines made in India.
Usually I travel at this time to India, you know, I plan my trip and I come usually every year. And it was so nice to meet most of you last year. It was a very nice experience. And yes, I hope very much we will meet again in person on the holy ground.
We'll plan more experiments related to, metamaterials like graphene or its equivalent, its doping, then probably the attenuation of the neutrinos in the graphene-like material, which partly converts its kinetic energy into useful energy. So there are many things we'd like to discuss with you in person. Whenever you and Dr. Holger, probably whenever you come to India, I would like to have more interactions with you. May I now request Dr. Bhatkar to offer a few concluding remarks? Dr. Bhatkar, please.
Thank you. I think it has been a very, I think amongst the several webinars we had on this topic ever since Dr. Volgar initiated this, and it was taken up by CMED with all enthusiasm and hope. This has been a wonderful, I think, learning experience, particularly, I think, say, Dr. Boraskar's, I think the exposition, I think, clarified. It's like a teacher, the whole field, which is we are not. I think we don't come from this field, and there was so much to, I think, wonderful to understand in a very short, a comprehensive lecture, I would say, and so much to be learned. Holger had given us the whole picture, and from the perspective of really translating. This is a translational research. I think how do we translate this, the amazing theoretical possibilities and what the nature exhibits into a practical field, in a pragmatic, practical, and which translates for the world. And we said about there are several peaceful applications possible when we are going through the biggest challenge of what you call the climate change and the energy requirements as they are growing. So it was a wonderful thing. I think it is, as we learned the fundamental foundation, we also learned the challenges in translating this fundamental research into actual practical applications, where we need, of course, collaboration across so many experts. So it was one good thing, very, very good thing. And we require more of these. And Dr. Boroskar, when you come to India and we are available, we'd like to go through your classes, go to really learning, because we don't come, I mean, at least I don't come from this field. And we missed Ludwig's, Dr. Ludwig's slides, but you explained in without the slides, so what you wish to do, and particularly your interest, which is coming into very important issue, that how your thoughts can interact with the next generation materials, at least, and how can capture that. So this is a great, I think, challenge, a great curiosity for the humanity, how materials in energy and thoughts can interact with each other. So there are many implications in the information technology, artificial intelligence, and all that kind of things on that. But that will leave it to the next, some other very exotic seminar, which we will have with also the philosophers and thought leaders of the world. So I think it led to wonderful thing. We talked about so many possibilities in the 0-point energy level, which I think Akshay was introducing us. That also will leave it to some other day, thing, some other time, which will require some great people to come. But I think what is important is that it is now spinning off many possibilities, and I think Dr. Kyle will be very interested. I think it is very satisfying that the lab is now entering into the very frontiers of knowledge in the materials field. When we were talking about that, and I think a lot to be learned. So thanks to everybody, and I would say before I say thanks, I think there is a Thanksgiving ceremony or thoughts to be expressed. I'm very enriched, and I'm very happy about this. Thank you very much.
Thank you, sir.
Now, I think before
definitely we'll take forward this materials part in CMED. And again, we'll have a meeting with them on 8th of March. That is CMED Foundation Day. So we'll invite Professor Holger and Ludwig. Again, we have international conference along with Foundation Day. So 9th and 10th, we can have Professor Holger, then Professor Ludwig, and as well as Professor Boraskar, because this one will have a very separate session for the neutrino. Okay.
Satellite session for neutrino. Satellite.
Yeah, one session will be on neutrino.
Satellite session.
Satellite session. Yes. So Akshay is there, no?
Yeah. Akshay, can you propose the formal vote of thanks?
Yes, sir. Thanks for giving me the opportunity to give the vote of thanks. Honorable dignitaries, distinguished guests, respected President Director and past Executive Director of CIMIT Pune, I feel immense pleasure to take this opportunity to propose a vote of thanks to our patron and eminent speaker, Dr. Vijay Pandurang Bhatkar sir. Sir, I would like to convey my sincere gratitude from the deepest corner of my heart to spare your most precious time in spite of your busy schedules to grace this webinar. In your extremely relevant speech on the application of nuclear energy in Indian scenario, that have given us the insight to conduct our research and development activities on nuclear energy and the development of nuclear voltaic technology that will ensure an energy independent and climate friendly ecosystem for the future generations to come. I would extend my hearty thanks to our other patron, Dr. Holger Thorsten Schubert, CEO of Neutrino Group Berlin, Germany, for his thought-provoking keynote address on nuclear energy, harvesting, and the role of nuclear energy group. Dr. Holger has rightly pointed out that this cosmic neutrinos in fact has mass that was confirmed in 2015 by two Nobel laureates, Dr. Takai Katija and Dr. Arthur B. MacDonald. Anything that has mass also has energy associated with that, and the Neutrino Energy Group has just developed the technology that can harvest the energy from the neutrinos. I take this opportunity to specially express my deep regard and gratitude to our invited speaker, Professor V.N. Boraskar sir, for explaining us the origin, types of neutron particles, and their detection. Sir, your lecture has created a deep insight among all of us that we are literally submerged in an infinite ocean of highly energetic cosmic radiations. And now we realize that the time has finally come that humanity must develop technologies that can harness these cosmic radiations to meet the day-to-day energy requirements. I also extend my hearty thanks and gratitude to Dr. Thorsten Ludwig for joining us on this webinar and enlightened all of us through his lecture on the designing aspect of the foil made up of metamaterial that can interact with the cosmic neutrino radiations and convert it into direct current output. I respect him as my guru, as I have been following his research papers and books on zero-point energy, which is also my area of research interest. Thanks, sir, for joining us on this webinar. I also convey my sincere thanks to Dr. Bharat Kale sir for organizing this webinar and delivering the introductory remarks. My special thanks to Dr. Dinesh Amnarkar sir for being with us on this occasion and introducing the speakers to us. My deep sense of appreciation and sincere thanks to all the participants who choose to be live with us and attend our webinar with great enthusiasm and made it a very successful event. My special thanks and deep gratitude to our beloved and divine sister Brahma Kumari Gudi Didi, who always remain us and shower her spiritual blessings on all of us. Without her spiritual inspiration and support, it would not be possible to get the desired progress in our research and organizing this webinar. I convey my special thanks to Dr. Yogesh Shetty and Dr. Sudhir, together with all this technical support team and the organizing committee of CIMET Pune for their most valuable support and helping us to webcast our webinar through Zoom and YouTube. Once again, I personally thank you all for being with us in this beautiful winter morning and afternoon session of our webinar. May God bless all of us on our noble mission in bringing a noble and art-serving energy technology for the well-being of the humanity. I wish you all have a wonderful day ahead. Thank you very much, sir.
Thank you.
Thanks, sir.
Dr. Kale, please.
Thank you very much. So if you let me give some last words, because finally I have this call again to everyone who understand what we have said here today. So today we have the recognition that we have the access to this kind of limited cosmic energy. I say cosmic energy, not only neutrinos. So without any doubt, we know that we have enough energy. And of course, the technical application are the beginning. This is the beginning. But we know it works. And now it's simply our duty to use that knowledge and a lot of money. And I will do that. So I'm very happy to have CMAT involved now. And something is totally clear. This is not a question of a 5 million or a 10 million or 100. It will be a question of billions. And we as the Neutrino Energy Group will making our IPO, we will bring these shares to the market, and we will use the money to doing exactly that research what Dr. Ludwig told about. So we need to know more, but we have some knowledge, and this knowledge is not only promising, this knowledge is more. This is a proof. We already have a proof. And now we all together in this group, it's simply our duty to use the knowledge. We will arrange the money, and we will make life on this planet better. This is my promise to everybody, and I will give my best for more peace and freedom for the children and the future generations. And I was very happy that I have the opportunity today to speak some words to all of you. And I wish you all a nice weekend now. So all my best wishes from Germany. Thank you very much and goodbye.
Thank you, sir. Thank you. Thank you, sir.
Yes.
Thank you.
Dr. Kai, yes.
Yeah, we have a national, we'll have a national anthem from our Govinda, one of our student. He's insisted. So we'll Govinda, please.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you everybody.
Thank you. Thanks to all.
Thank
you.
I think let's close the webinar today. Thank
Thank
you.
you.
Thank you, Dr. Kai.
Thank you. Thank you, Rath. Are you happy?